You take a breath right now. The oxygen that fills your lungs came from somewhere. A good portion of it was born in the Amazon rainforest. You probably imagine the Amazon as a self contained world of rain and rivers. But its true lifeline is far stranger. It comes from one of the dreariest, deadest places on Earth. How does a dead desert feed a living forest? There is a desert basin in the heart of Africa. It sits in northern Chad between two ancient mountain ranges. The Tibesti Mountains rise to the north. The Enedi Plateau rises to the east. Between them lies a natural wind tunnel. This is the Bodélé Depression. The ground here is not ordinary sand. It is made of the crushed remains of uncountable microscopic life forms. These are diatoms, tiny algae that once floated in a giant lake. That lake vanished thousands of years ago. So how did this lake bed become a source of life for the Amazon? The diatoms died and settled to the bottom. Their silica shells formed a thick, powdery layer. Today, the sun bakes this layer into a fine dust. The winds that funnel through the mountains pick it up. And what happens next is one of the most important journeys on Earth. The dust is launched into the sky. It rises thousands of feet into the atmosphere. The winds carry it westward over the African continent. Then it crosses the Atlantic Ocean. But can dust really travel an entire ocean? The journey takes about a week. Scientists have tracked this dust plume from space. NASA satellites named Calypso and Modus watch it happen every year. A NASA researcher named Hongbin Yu studied these plumes for years. He found that the dust forms a continuous airborne river. This river flows from Chad to the Amazon basin. It is invisible to the human eye from the ground. But from orbit, it looks like a pale veil stretching across an ocean. That veil carries something the Amazon desperately needs: phosphorus. Why does the wettest forest on Earth need a nutrient like phosphorus? Your body needs phosphorus too. It builds your DNA and your bones. In a forest, phosphorus is just as essential. It fuels plant growth. It is the bottleneck nutrient in many tropical soils. And here is the paradox. The Amazon, the wettest forest on Earth, grows on some of the poorest soil. How can that be possible? The heavy rains wash nutrients away almost as fast as they arrive. For millions of years, the forest held on by recycling its own dead. But even that is not enough. Over vast timescales, phosphorus seeps out through rivers. The forest bleeds phosphorus. It needs an external source. That source is the dust from Bodélé. But how much phosphorus does the forest actually receive? A geologist named Charlie Bristow understood this better than almost anyone. He traveled to the Bodélé Depression to study its dust storms firsthand. He and his team camped in the white, cracked landscape. They measured the winds and collected dust samples. They discovered something remarkable. The dust contains high levels of phosphorus bound to the diatom skeletons. When the dust falls on the Amazon, the phosphorus becomes soluble. Rain and soil acids unlock it. The trees can then take it up through their roots. It is a delivery system of extraordinary precision. The amount of phosphorus delivered each year is almost exactly the amount the forest loses. About 22,000 tons of phosphorus fall from the sky onto the Amazon annually. This number comes from a NASA-led study by Hongbin Yu and his colleagues. They matched the dust deposition rates with the nutrient balance of the forest. The numbers lined up with eerie accuracy. It is as if the desert and the forest have negotiated a contract. But how did this contract come to be? The story goes back thousands of years. The Bodélé Depression was once the deepest part of an enormous lake. Paleolithic Chad covered an area bigger than the Caspian Sea today. It was an inland ocean, and it teemed with life. Over millennia, the lake shrank due to climate shifts. The diatoms that lived in its waters died in vast blooms. Their silica bodies accumulated on the lake floor. When the lake finally dried, the diatomite was exposed. The bones of a dead lake became the skin of a new desert. And that desert now feeds the living system on the other side of the world. Can you trace a single grain of phosphorus from that lake to the Amazon? Think about what this means for any drop of rain that falls on the Amazon. That rain nourishes a ceiba tree whose leaves contain phosphorus atoms from Chad. The phosphorus was lifted by a windstorm in Africa. It traveled over 5,000 miles of ocean. It fell with raindrops into the soil. A root hair absorbed it. The tree used it to build a flower. A bee pollinated that flower. The flower became a fruit. The fruit feeds a monkey. The monkey breathes out carbon dioxide. The ceiba tree uses that carbon dioxide and the same phosphorus to grow again. The loop closes. But the origins of that loop are always in the dust. This is not just a curiosity. It is a lifeline that keeps the Amazon from slowly withering away. Without the dust, the forest would lose its phosphorus bank over many centuries. The lush canopy might thin. The wildlife would follow. The rain patterns might shift, and your own breath would change. Because the Amazon produces roughly 6% of the world's oxygen, and it stores a massive amount of carbon dioxide. The dust from a dead lake helps keep a living planet stable. Now consider the timing. The Bodélé dust storms are most intense during the winter months. That is when the trade winds are strongest. By the time the dust reaches the Amazon, it arrives at the start of the rainy season. The first heavy rains wash the dust out of the air. The phosphorus dissolves and enters the soil just when the trees need it most. It is a seasonal pulse of fertility. The system is not random. It has a rhythm that has repeated for thousands of years. You might say the rainforest breathes in sync with the desert. But is this rhythm endangered? Yet this rhythm is fragile. The Bodélé Depression is one of the windiest places on Earth. Its dust storms are powered by a specific wind called the Harmattan. Climate change may disrupt these winds. Or it may shift the rainfall over the Sahel, which stabilizes the dust source. If the Bodélé becomes wetter, the dust may cease to fly. If it becomes even drier, the diadem crust might harden and reduce erosion. A geologist named Nick Drake warned about this delicate balance. He and his colleagues showed that slight changes in wind speed can drastically alter the dust output. The future of the Amazon depends partly on what happens in a small corner of Chad, and so does the air in your lungs. The Amazon is often called the lungs of the earth. But a lung cannot breathe without its own source of nourishment. That nourishment comes from the remains of an ancient lake. It comes from one of the most desolate places on the planet, a place where nothing lives. Yet, that place gives life to the most biodiverse forest in existence. You have never been to the Bodélé Depression. You may never see it, but its dust is in your body. Every breath you take carries a trace of that story. The phosphorus that built the Amazon's trees may have entered the fruit you ate years ago. It may have become part of the fish in the river that eventually reached the ocean. The chain is long and invisible, but it is real. The world is far more connected than it seems. How was this hidden system finally proved? This hidden system was only proven in the last 2 decades. Before satellites and chemical tracers, scientists assumed the Amazon was self-sufficient. But the evidence now is undeniable. The soil profiles in the Amazon show a clear signature of African dust. The isotopes of neodymium and strontium in the soil match the Bodélé source. The airborne dust measured over the Atlantic matches the deposition in the forest. A team at the University of Leeds has mapped these signatures. Their work confirms that without this dust, the ancient basalt soils of the Amazon could never support the massive growth. The forest literally rises from the dust of a dead lake. Can you feel that connection now? You walk outside on a humid day and you feel the air thick with moisture. You might think of the Amazon as a distant green blanket on another continent, but the water cycle connects you. The same Amazon that receives the African dust also releases massive amounts of water vapor. Those clouds travel to other regions, bringing rain. The dust nourishes the trees. The trees pump water into the atmosphere. That water falls on crops and cities thousands of miles away. Your weather may be influenced by a dust storm in Chad. When you breathe, you sense the desert. And now, whenever you hear about the Amazon rainforest, you can picture the invisible plume. You can see the white plain in Chad baking under a 120-degree sun. You can hear the Harmattan wind howling through the Tibesti canyons. You can imagine the dust rising, traveling, settling on a leaf in the Yasuni Basin. That leaf absorbs a drop of water and a grain of phosphorus. That grain is older than human civilization. It was formed inside a microscopic diadem in a lake that covered an area larger than your country. It waited for 10,000 years in the desert, and then it flew. That is a real story of the Amazon. It is not just a forest. It is a conversation between a dead lake and a living jungle. And you're part of that conversation. Every breath you take ties you to that grain of dust. The next time you see a photograph of the Amazon, look not just at the green, look at the sky above it. An invisible bridge stretches eastward. It crosses the Atlantic in silence. It carries the bones of an ancient world to the lungs of this one. And it has done so since before you were born. The forest breathes because the desert breathes. So when you take your next breath, you know where it truly comes from.
If you enjoyed this video, please subscribe to our channel. A new story every week.